Hi, welcome to this video on phosphate sensors. So I've got a mixture between introducing the phosphate sensor and discussing the phosphate sensor, but at the same time also answering some specific questions that have come in on the phosphate sensor. So the first thing somebody's asking is, should they be using RO water, reverse osmosis water? I think reverse osmosis water is actually quite a bad idea, and I'll get to that in a minute. Can they test by dropping samples onto sensors, or will they have to put it in a beaker? You can do both, and I'll get to that. And should they increase the phosphate concentration? I think the answer is yes. When it comes to reverse osmosis water, it's very pure water. So normal tap water might have 1,000 ppm of total dissolved solids, whereas reverse osmosis water may have 10 ppm of total dissolved solids. So if you're trying to test RO water, I think it's a really bad idea. We use RO water in the lab all the time, but we use it to prepare buffers. We don't test the RO water specifically. If for some reason you do want to test RO water, you're probably better off taking your RO water, adding a solution with electrolyte in it, something like 150 millimolar sodium chloride, and then measuring with that solution. In that case, you'll have to times your measure result by 2 because you've effectively diluted your sample by a factor of 2. So now the reason I'm sort of not really favouring, or one of the reasons I'm not really favouring RO water is because we've got a reference electrode on here and we've got a working electrode on here. I doubt the working electrode cares too much about the RO water, but the reference electrode, we have silver chloride, so it's expecting to be operating in a chloride solution, which is not a bad expectation because many natural samples, be it seawater, even be it tap water to some degree, be it blood, be it urine, they all have chloride in them. But RO water doesn't have chloride in it. So that can actually end up meaning that the reference electrode is not the stable reference electrode that we need it to be. So you can end up getting some pretty screwy results, I suspect, with reverse osmosis water. The other thing about reverse osmosis water is, whereas drinking water might have a conductivity of 200 to 800 microsiemens per centimeter, reverse osmosis water may actually have orders of magnitude less conductivity than drinking water, more like 0.05 to 10 microsiemens per centimeter. So that is a big difference. Reverse osmosis water is not just pure water, it's quite different from other sources of water. So I'm not a great fan that you would just be able to test low concentrations of phosphate in reverse osmosis water. You need the other salts in there, like the chlorides, etc., to help with conductivity and also to help with reference electrode. Now, when we're testing, we do drop testing. So when I look at this data, that'll be 10 micromolar. That'll probably be 100 micromolar. That'll be 10 micromolar. That'll be 1 micromolar, and that'll be 0.1 micromolar. We also would do beaker testing as well, where we'll put the sensor in a beaker and we'll stir and we'll spike in phosphate concentrated solution into that and measure the signal accordingly. It's probably worth saying that if you, not this person, but other people, if you're interested in our phosphate sensors, I don't like we call it calibration solution. This is a test solution, but we do a test solution that will help you test our sensors. Now, I may have to correct myself here because I can see that those solutions there are 0.1 millimolar, 1 millimolar, 10 millimolar. So that's probably the kind of concentrations that we're used to testing those sensors on. So if I just scoot up and we're just making comments earlier on, that would be 10 millimolar, that may be 100 millimolar, that may be 10 millimolar, 1 millimolar, and 0.1 millimolar. So it is easier for us to measure higher concentrations. If you're in the 1 micromolar, then that might be a little bit too low. We don't think it will produce stable results in RO water. Too high a conductivity, too low a chloride concentration. You can do it by dropping or by stirring. That I don't have an issue with. And if you look at our test solutions, you should try testing those concentrations before you go to lower concentrations. But of course, if you've got any questions, now I only got these 3 questions on Friday. Today is Saturday, so I do want to make that statement that we do, when we understand the questions, we will offer rapid support. Okay, thanks very much. Take care. Bye bye.